Hello everyone, today let's solve the problem number 518, coin change 2. We have already solved the coin change problem, right? So this is similar to the same problem. So similar to the coin problem 1. Sorry. So what the question states here, we are given an array coins. You can clearly see here, we are given an array coins here where each element represents the different denomination of coins. So here each element represents different denomination of coins. We can consider this one 1, 2, 5. These are different, right? So where each element represents the different denominations of coins. Suppose if you consider this one in rupees, this will be 1 rupee, this will be 2 rupees, and this will be 5 rupees. Each coin denomination is different here, value. So and then integer amount, we have an integer amount as well here, which is the total money we need to form using these coins. So using these coins we have to sum up to the amount, right? That's what they have said here. So we can use coin an infinite number of times. So we cannot we can use these coins infinite number of times. You can use it any number of times, right? So that's what they have given here. We need to determine the number of ways to form the amount using the given denominations. If it's not possible, then we have to return 0. Here again I'm telling, we need to determine the number of ways to form the amount. Number of ways to form the amount means number of ways to form 5 here using these coins for this particular example. So we need to determine the number of ways to form amount using the given denominations. If it's not possible, then we have to return 0. In the example 2, you can clearly see it is not possible here. So in that case, we have to return 0, right? So this is one thing we have to keep in mind. Let's come to the example here. So in the example, the first, this one, input amount 5 we have, and the coins we have is 1, 2, 5. So these are of different denominations, 1, 2, and 5. So explanation they have clearly given here. There are 4 ways to make up the amount. One is we have only this one coin, 5, 1, 2, and 5 we can use. 5 only 1, 5, this one coin will lead to amount 5, right? So two coins and one coin, this one we have here, this will also lead to sum 5, right? 2 plus this one, suppose if we consider this one rupees, so 2 rupee coins and 1 rupee coin in this case, right? So this will also lead to 5. 2 plus 2, 4, plus 1 is 5. So we have here 1 2 rupee coin and 3 1 rupees coin. So this will also lead to this one 5, 2 ones and 1 here, 3, right? So this will also lead to 5 here. So finally 1 rupee coins, if we have 5, this one, this will also lead to 5, right? So these are the possible ways to sum up to the amount. So we need to find the number of possible ways to sum up to the amount, right? So these are the 4 possible ways. So we have to return the number of possible ways here. The output that they have given here is 4, right? If it is not possible, then we have to return 0. Let's come to example 2 here. Amount 3, coins we have only 2. So this is even, right? So this one, however we sum up, however times we make use of this coin, it will lead to even number itself, 2, 4, 6, 8. It will not lead to sum 3 at all. So output will be 0 in this case. So here amount is 10, coins 10. So there is only one way, 10 itself, right? So 10 rupee coin we can make use of if we consider this one in rupees. So this output they have given here is 1. So I hope the question is completely clear, right? So let's discuss the approach initially, followed by edge cases one by one, and then finally write the code, and let's discuss the complexities of the code that we have written. So the first thing that we'll do, as usual, we'll discuss the approach, right? I'll just be considering the example 1, the same example that they have given in the question. I'll just be considering the same thing here. So let's discuss the approach first. So let's discuss the approach step by step. So first thing we have to keep in mind here is we are we'll be making use of 2D dynamic programming, right? So we'll be going with the dynamic programming. Just keep this in mind. So we'll be going with the 2D dynamic programming. Just keep this in mind as well. So example, I have considered the same first example that they have given in the question. 5. So coins 1 to 5, that leads up to the sum 5. We have to find the number of ways that sums up to the amount here, right? This one. So this is fine. Let me just do this one. This is fine. So yeah, output has to be 4 here. Number of ways is 4 here in this case. So this is fine. So let's see the same thing step by step. So let's come to the initialization part. Initially, what we will do, so we will create a 2D DP table as we have discussed first. So this will be DP of ij, right? We are creating a DP table. DP of ij represents the number of ways to make j amount using the first I coins. Just keep this in mind. This is fine. Just for the, so here let's go with the base case first. So when I say base case, DP of I0 is always 1. This one, DP of I0, this is 1. Why this is 1? Because there is only one way to make the amount 0. So here we are considering 0, right? This is 2D double. So there is only one way to make the 0, that is considering no coins at all here, right? So we don't have to consider any coins to form 0. That is the only way to make the amount 0 by taking no coins. So this we will initialize first. This is the initialization part. So I'll just write here 1, 1, 1 and 1, because we have 0 here. You can clearly see 0, 0. So this is fine. All other cells will be initially 0, right? This is fine. I hope this is completely clear. So this is the initialization part. So DP of I0 is always 1. There is only one way to make up to the amount 0. One way to make amount 0, right? So I hope this is clear. Let's come to the second step here. So when I say second step, we have to process each coins, right? Process each coin in the sense 1, 2 and 5. We have this one in the array. Coins they have given. Either we can consider 1 here, or we can consider 2, or we can consider 5, right? Let's try every combination. First, we will be making use of coin 1 here. When I equals 1, right? We can just go with the formula here. DP of ij here, DP of ij equals DP of I minus 1 j plus DP of j minus coins of I minus 1. This is fine. I hope this is clear. So this is the formula that we will be going with. So I hope this is completely clear. So here first what we will do, DP of 1, 1 is here, this one. So here this one we have already given. There is only one way to make up to the amount 0, right? So this one we can consider 1. So initially what we will do, we have to go with 1. We are going with this one, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, right? So this will be what we'll consider, DP of 1, 1, 1, 2, 1, 3 and 1, 4 we will consider, right? 1, 4 and 1, 5 we have to consider. So DP of 1, 1 according to the formula is DP of 1, 0 plus DP of 0, 1. Nothing but DP of 1, 0, this one, plus DP of 0, 1, 0, 1, this one. So initially we have 0 here, right? So we have 0 everywhere, except we are doing it for 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, right? So let me fill this one with zeros initially. So this one will be initially DP of 1, 0 plus DP of 0, 1. This will be 1 plus 0. This will be 1 itself, right? So next step, DP of 1, 2 we are going with. For DP of 1, 2 according to the formula, it is DP of 1, 1. This one again, DP of 1, 1 plus DP of 0, 2. This one. So 1 plus 0 again it is 1. DP of 1, 3 it is DP of 1, 2. This one, DP of 1, 2 plus DP of 0, 3. Here you can clearly see this one will be again 1 plus 0 will be 1. So for dp of 1 comma 4, it will be dp of 1 3 plus dp of 0 comma 4. 1 plus 0, again it will be 1 itself, and the final one, it is for this also, it will be 1 itself. It will be dp of 1 comma 5 equals dp of 1 comma 4 plus dp of 0 comma 5. This plus this 1 plus 0, again it will be 1 itself. So this is for using coin 1, right? So I hope this is clear. We are just going with this formula, just remember, right? So next what we will do, let's go with using coin 2, when I equals 2, right? So using coin 2, so the same formula will be going with, right? So here let me fill this one for the initial one. So this will be 1 1 1 1, and this will be 0 itself, right? This will be 0 itself, and this one we have already got from the previous one, 1 1. So this time we will be going with, we have to calculate for 2 2 comma 1 2 comma 2 2 comma 3 2 comma 4 and 2 comma 5. This will be again 0 for this particular step. This will be 0, right? So here what we will do, again the same formula, dp of 2 comma 1 is nothing but dp of 1 comma 1. This is equivalent to dp of 1 comma 1, nothing but 1 in this case. We will update 1 here. This is fine. The next step here is dp of 2 comma 2. dp of 2 comma 2 here is dp of 1 comma 2, this one, dp of 1 comma 2 plus dp of 2 comma 0, this one, 1 comma 2, this one, 1 comma 2 plus 2 comma 0. 1 plus 1 here will be 2 in this case, right? So dp of 2 comma 3 will be again same thing, dp of 1 comma 3 plus dp of this one, 2 comma 1, this one plus this one, right? 1 plus 1, again this will be 2 as well. Let's go to the dp of 2 comma 4, 2 4. dp of 2 4 is dp of 1 4, where is 1 4, this one, dp of 1 4 plus dp of 2 2. So this one will be going with, here 1 plus 2 is nothing but 3 in this case. I hope this is clear. The final one, 2 comma 5 here, dp of 2 5 is dp of 1 5, we are considering here this one, and dp of 1 5 and dp of 2 3. Where is 2 3 here? This one. So this one will be 1 plus 2, again this will be 3, right? I hope this is completely clear. We got here, right? 1 1 2 2 3 3 1 1 2 2 3, right? I hope this is clear. This is for using coins, using coin 2 when I equals 2. Let's move on to the last coin. When I is 5, 1 2 and 5 we have, right? When I is 5, sorry, when coin equals 5, when I is 3 here, right? So finally, so let's fill the table, initial ones from the previous steps. 1 1 1 1, this will be same, this will be 0 0 0 0 0, this was 1 1 1 1 1, this one 1 1 2 2 3 from the previous step. So the final step here is, we have to go for 3 comma 1, dp of 3 comma 2, dp of 3 comma 3, dp of 3 comma 4 and dp of 3 comma 5. For dp of 3 comma 1, it is equivalent to dp of 2 comma 1. This one we will be considering. So this will be 1 itself. I'll just write 1 here. This is fine. So dp of 3 2 is dp of 2 comma 2, this one. So I'll just write 2 directly here. dp of 3 3 is nothing but dp of 2 3, this one. Again I'll consider the same thing here. dp of 3 4 is nothing but dp of 2 4 here, nothing but 3 here. dp of 2 5 here is dp of 3 5 here, sorry, this one. We have to return the same cell, right? So as the output as well, 3 comma 5, the final cell. So dp of 3 5 is dp of 2 5, this one, dp of 2 5 plus dp of 3 comma 0. This one is nothing but 3 plus 1. In this case it will be 4 for this one, last one. So the last cell one what we have calculated, this one will be the output in this case. So this we have to return as output. I hope this is clear. dp of 3 comma 5 is nothing but dp of 2 comma 5, this value plus dp of 3 comma 0, this value 3 plus 1 is nothing but 4 we got, right? So that is how we got 4 here. This we have to return as output. Final output dp of 3 comma 5. We can clearly see this cell dp of 3 comma 5. This one will be 4 in this case. So this is same or equivalent to the output that they have given in the for the example 1, right? So output here is 4, and the approach that we went with here is dynamic programming 2D DP table or 2D DP. Here the output that we got here is 4 as well. So the approach works absolutely fine. So you can try the same thing for example 3, or you can just try with other examples as well. So I'll just be considering some of the edge cases. You can consider that example and try it out in the same way. So this will be the approach we will be going with. I hope the approach is completely clear. Now let's discuss the edge cases very quickly, right? So the first edge case that we'll be going with here is this one. No possible ways to form the amount. Here amount is 3, coins 2 they have given, we have considered. So output will be 0 in this case. So 3 cannot be formed using 2 at all. This one we have already discussed in the example, right? I hope this is clear. Second edge case that we'll be going with here is only one way to form the amount. So amount is 10 they have given, coins also 10. So there is only one way, that by using the 10 rupee coin. Here if we consider this one in the rupees, so this will be 10 rupees. So third edge case here is when amount is 0, it should always return 1, right? There is only one way to make amount 0. We have discussed this one in the approach as well in the step 1 itself, base case. If you remember, this one will be quite obviously 1. There is only one way, that is considering no coins at all, right? So these are the 3 edge cases that we need to consider. First one was for no possible ways to form amount. Second one was for only one way to form the amount, and the third one was for amount equals 0. When amount is 0, it should always return 1. So I'll just give here, when amount equals 0, it should always return 1. So I hope these edge cases are completely clear. Now let's start writing the code. I hope the edge cases as well as the approach that we went with by taking or by considering the first example is completely clear. Now let's start writing the code. Here let's start writing the code now. So first thing is we'll be making use of the length of the coins. So I'll just assign that one to one variable. So I don't want to write a length of the coins dot length every time, right? So I'll just give here n equals coins dot length. So just give here n. This is fine. So we'll be making use of the dp table, right? So let's assign the dp to array. So this one we will be going with the array of size n plus 1. We'll just make use of fill. So we are going with the 2D dp, right? So I'll be making use of map here. Let me go with map here. This one will be array of amount plus 1. This is fine. This one dot fill of 0. So we are filling 0. We are filling with 0. So rows and columns we have considered here initially. So as we are going with the 2D dp table, so this will be of the length amount plus 1. This will be of length n plus 1, and this will be of length amount plus 1. This is fine. Amount plus 1 and n plus 1. This is just for the easy computation purpose. We'll be making use of it, right? So here, if you are considering 5, this will be amount plus 1 is nothing but we will be having 6 columns, and we have to go with 4 rows, right? So this is one thing. So first thing, base case, we have already discussed this one. There is exactly one way to make the amount 0 by taking no coins, right? We have discussed this one multiple times. So how can I articulate that one in the form of code? Let me take the simple for loop here. Let I equals 0, I less than or equal to n. Let me increment the I here. So here for this, I'll write this one directly. dp of I and 0. This will be, there is only one way, right? So I hope this is clear. So let me come here. Just give me a second here. So yeah, next, after considering base case, we have to process each coin one by one. We saw that one, right? Coin 1, coin 2, coin 5. We considered this example, coin 1, coin 2, coin 5, and we processed each coin by considering here I equals 1, when I equals 2, and when I equals 3 we considered coin 5. When I equals 1 we considered coin 1, when I equals 2 we considered coin 2, when I equals 3 we considered coin 5, right? That's what we have to articulate that one in the form of code. How can we write? So let's see how can we write the same thing. This one will be for let I equals 1, I less than or equal to n, and this one let's increment the I. This is fine. So the next step here is for let j equals 0, j less than or equal to amount j plus plus. This is fine. So here we are just processing each coin one by one. Why two for loops here? Because we are going with a 2D DP. So here within the for loop, what we have to write? So case 1 we saw, we don't have to use the current coin, right? So when not using the current coin, so this one I can write this one and this way: dp of I j, dp of I minus 1 and j. This is fine. So the next step here is case 2, using the current coin if possible. We have to make use of current coin, or when not using the current coin. So either there are two ways, right? So when we are making use of the current coin if possible, so if simple if condition, yeah, coins I minus 1, this one less than or equal to j, then what we will do, dp of I j equals dp of ij plus this one formula. So we already know this one: dp of ij plus dp of I j minus coins, right? J minus coins of I minus 1 within the array. So this is fine, I think. So I hope this is clear. So the final step here is we have to return the answer. Nothing but the answer is the number of ways to form the amount using all the given columns. The final this one cell dp of 3 comma 5 in this case, in the example that we considered, we returned dp of 3 comma 5. That we have to return, right? The final answer, the answer is nothing but the number of ways to form amount using all the given coins. So here we will return n, sorry, dp I have to mention here, right? So I forgot this one, dp of n and amount here. So let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed here. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed here. So the code works absolutely correct in this case, right? So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is 2D dynamic programming or 2D DP, right? So overall time complexity here would be, for this code whatever we have written, it would be n into amount. So why it is n into amount? Because we are iterating over n coins and amount values. You can clearly see here we are iterating over n coins. You can clearly see here, right? We iterate over n coins and amount values. So overall time complexity would be because of n into amount. So what would be the space complexity here? Overall space complexity would be here because of n into amount as well. So why it is a because of n into amount here? We are maintaining a DP table of size n plus 1 into amount plus 1. You can clearly see here DP array. So DP table here, we are maintaining a DP table of size n plus 1 into amount plus 1. Just for the sake of easy computation, we are going with n plus 1 and amount plus 1 here, right? So this is 2D DP table. So n plus 1 amount plus 1 here. We are maintaining a DP table of size n plus 1 into amount plus 1. So overall space complexity would be because of n into amount as well. So overall time complexity and the space complexity of the code that we have written is because of n into amount. So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.